Good day guys, welcome back to the TheKnowHow channel. So quick small thing. The people commission systems by just switching on and walk away, and then I'm like, guys, stop the loading. You need to believe in this little book and understand this book before you switch on the system. So guys, there's basic principles. I can tell you of nice stories. Guys switch on the system, the coffee machine burns out, and this burns out, and that burns out, and then I can tell you a story where clients' TVs popped, and yeah. Because, guys, this little box, this little step I'm going to show you is going to take 15 minutes, but I promise you it will save you a lot of money over a long time. Okay, so guys, basically where I always start to believe, SANS tells us your products need to be bond and bond. Your electric equipment, your MPPT, this and your battery must be all on the same value. So I always said, take your system. Guys, just note, I don't believe in testing my system with grid on or whatever, because we work on off-grid scenario now, because you have to test your system to work safely when Eskom is disconnected. You cannot rely on a client's earth point or bonding point outside to keep the neutral and earth bond. So we want to see that the neutral and earth is bond on your inverter's output to your client's house. We want to make sure that there's no voltage difference between neutral and earth on your supply side of your inverter. We want to make sure there's no bonding. So guys, this installation is not perfect. It's not at client's house. This is in a training center under worst conditions to show you what's wrong, what must be done. So guys, SANS regulations say bonding need to be under 0.02 ohms. So if I take this tester, it's on ohm scale. If I test to this earth nut here, it's 0.2 ohms. So it means the bonding is correct to this inverter. But if I click it on my battery here, there's not even continuity. So there's no casing earth. So guys, this casing needs to be earth because it's power flow to the casing. If I measure to my MPPT, here's the earth up on the side, there's no earth, visual earth. It's also 1.2 mega ohms, so there's no bonding to the MPPT. Guys, but we are ready to switch on, the power is there. We're switching on already. So yeah, okay. Guys, that is basic principles, okay? You want to put your tester on voltage. If you know what you do, then you leave it on the ohm scale, and you put it on your inverter's output, your neutral. And your neutral should be less than 2.2 ohms, it means it's bonded. If you put it on voltage, AC, your AC side and your should be 230 because inverter's output set to 230. The neutral should be 0. Guys, yeah, as long as it's close to 0, yeah, I'm happy. Okay, so there's 1.5 millivolts that I'm picking up there. Okay, voltage will pick up 230, so that's correct. So guys, if you know this is the output, I always tell guys, because there's changeover switches. Sometimes the guys put the neutral the wrong way around, the input and output neutral, or the Eskom and the main neutral. So just by basically switch on your inverter's output, put your changeover switch into inverter position, test again on top of your changeover switch or your output breaker. Don't switch it on yet. Make sure neutral and earth is there. Check between neutral and earth that is correct, and between live and neutral. Guys, this is a stupid test, but this will make sure your polarity is the correct way around. So guys, if you switch around neutral and earth, live and neutral, everything will work in a client's house, except one product will work correctly. It can either trip immediately, or it won't work at all, and that's your earth leakage. That's the most safest thing you have to make work. So again, switch the load on, and the client, you can test in your DB on that side further. If your voltage come right on, switch on and do all the tests on that side. Okay, guys, and then on the MPPT side, this is just basic testing I normally do.